Okay, continuing with 5.1 of Honors Algebra 2, we're going to be graphing. Now, in this section or this video, we're going to be graphing by hand, showing the formula to find the vertex, the three forms of the quadratic formula. And I think it's important to do it by hand. I know we have the technology to do it on our calculators, and we'll be doing that as well. But I think it's important to do it by hand to show where all these pieces come from and how the equations are working or work with the actual graph, where the vertex comes from, how's the graph get fatter or skinnier depending on what's happening with the equation. So we're now going to go through one example of each of the forms. We have standard form, y equals ax squared plus bx plus c. Vertex form, y equals ax minus h squared plus k. And intercept form, y equals a, x minus p, and then x minus q. We're going to do one example of each. Each one's a little different, okay? But they're all going to be making a quadratic equation graph. And the quadratic equation graph, it's called a parabola. This is the general shape of the parabola, which is the basically smiley face or frowny face. Okay? It's not a linear graph like we had in the earlier chapters where it's a straight line. It's going to be a curve, either opening up or opening down. Now, I pointed out before that each of the equations had an a variable in it. This is how you can tell if the equation or if the graph's going to be opening up or down. Okay? Opening up and down is looking at the a variable. If a is positive, the parabola is opening up. If a is negative, it's going to be opening down. So when I just had those examples up there, I put them up again. The general form, opening up, is the smiley face, meaning that the lowest point, or it has a lowest point, and then it starts going up continuously. When it's opening down, it has a highest point. Okay? Now that point there is going to be called the vertex. That's either going to be our maximum or minimum point, depending on if it's opening down. Okay? So this point here, the vertex, okay, in this case, would be our min value. We can't get any lower than that point. Once it hits that point, if it's coming from the left-hand side, hits that point, then it starts going up. The vertex here would be the max. And that max, again, if it's coming from the left-hand side, hits that point and then starts going down. Nothing goes above that point. That vertex is an important point. That's one of the points you're going to have to show me when you do these graphs. So doing an example now, standard form, f of x equals ax squared plus bx plus c. Now it's very important to be able to identify what your a, your b, and your c is. For the vertex, okay, I always like you to label the vertex with a v, and then you have your ordered pair, that would be the point. Okay, that v is just telling me, okay, I know this point is the vertex. Now for the x, the vertex is negative b over 2a. Okay, that will give us the x coordinate. Now the way we get our a and b, just over here looking at standard form. The coefficients there for the quadratic and the linear term are our a and b. Plugging into that formula and go back, take that x value and plug it back in to the original equation will get us our y value. So for an example, we had y equals 2x squared plus 8x minus 2. Our a would be 2, and our b would be 8. So taking those values and plugging them in, we have negative b over 2a, which would be negative 8 over 2 times 2. Now take your time. If you're going to do this all on your calculator, make sure you do the order of operations correctly. Okay? We want to do the denominator first. 2 times 2 is 4, which gives us negative 2. Now taking that negative 2, plugging it back in will give us our y coordinate. So here we have 2 times negative 2 squared plus 8 times negative 2 minus 2. Okay, a lot of negatives there, so take your time going through this work. We should have 8 minus 16 minus 2 will give us negative 10. our vertex then would be -2, -10. And like the y-intercept for linear equations, that's our starting point. That's going to be our starting point for parabolas. Finding the vertex, that's the first point you plot, and we know, okay, it's either going to be opening up from that point or opening down. Okay, so there's finding the vertex. Very important you watch your signs for that one. Okay, let's go through a whole equation here. So we have y equals -x squared plus 2x plus 3. And the first step is to find a vertex. So again, I'm going to have that -b over 2a. Our a is -1. Our b is 2. Our c would be the constant of 3, but it's not in the equation, so I'm not going to bother labeling it there. Plugging this in, -2 divided by 2 times -1. This gives us -2, so it's not simplified to 1. Our x for our vertex is 1. Taking that, plugging it back in. Now, make sure you have that negative sign outside the parentheses when you're plugging that in. Putting it inside parentheses will give you a different answer. So we have -1 plus 2 plus 3. That should give us 4. So our vertex is 1, 4. Okay, so that's going to be our first point. That's going to be the first point I plot. 1, 4, which goes right about there. Okay, we have our vertex labeled over here with the V next to it, showing that we know that is our vertex. And now I'm going to draw a vertical line. This vertical line is called the axis of symmetry. Okay. It's not a part of the graph, but it's important to have that axis of symmetry. That shows you that's the middle of the parabola. Parabolas are going to be symmetric, equal on left and right hand side. That's going to help us draw a couple more points. And for a parabola, I would like to see 5 points. Okay? For a linear line, you can just have 2 points and draw the 2 points and connect those to have your line segment, draw through those 2 points to have a line. For a parabola, I'd like to see 5 points so we know exactly how fat or skinny our parabola is going to be and show if it's opening up or down. Okay? Now to get some more points on here, I'm going to make an XY table. And that XY table is going to help me pick some more points. Okay? You really have a lot of freedom. You can pick any X values that you'd like. My suggestion is to stay on the one side of the axis of symmetry. Okay? You don't want to go back and forth because points might start corresponding with each other and it's not going to help you as much, and you might see why when we finish this equation, take a couple more steps. So I usually just go, I know my vertex is at x equals 1. I'm going to pick 2 and 3 as my next 2 points. Right? You don't want to go too far away from our vertex, especially since we have a small graph there. The points might start going off the graph. Now what I'm going to do is to get my y values, just like I found my vertex, I plugged into the equation, I'm going to do that same work here. -2 squared plus 2 times 2 plus 3. -3 squared plus 2 times 3 plus 3. And see what we end up getting there. -4 plus 4 plus 3. That's only going to be 3. So our 1 point is 2, 3. Down here we have -9 plus 6 plus 3. That's only going to give me 0. We're going to have 3 zeros, our other point. So if we plot those 2 points now, we have 2, 3, 3, 0. And that should make sense. Okay? Our A is -1, meaning that it's going to open down. Our parabola is going to open down. So now we have our points, we can kind of start seeing, okay, we know this is our highest point. We come up, we're going to hit that point, and then start coming back down. Now the reason I draw that axis of symmetry is that's going to help me pick a couple more points. Since it's symmetric, we know if we have 1 point over here on the right-hand side, we have to have that same point on the left-hand side. So I'm just going to count. There's 1 away here. There's 1 away over there. 1 to the right, 1 to the left. 1, 2, 1, 2. Right there's our 5 points then. Without plugging any more points in, I was able to get 2 more points just with the fact that I know that it's symmetric. It's a mirror image over the axis of symmetry, and now I have my 5 points. And the last thing to do is to draw my line. Okay, there's my parabola. We have the highest point, the max value as our vertex, which is 1, 4, and it's opening down. Okay, so that's the example of standard form. Okay, you might want to take a look at the video again and just recount the steps here. Okay, step 1 was finding the vertex. Okay, that was just finding our starting point, and from there we know where our graph's going to start at, and that's going to be the highest or lowest point. Okay, step 2 is making an XY table to get a couple more points. Okay, so once we have those points plotted, then we can use the axis of symmetry to find 2 more points on the opposite side of that axis of symmetry. And then the last would just be drawing the line there. Okay, always make sure you're labeling your vertex. And once we do the other 2 examples, we'll see how we use this to actually solve the quadratic equation.